Hey guys, welcome back to my channel. Today we're going to do the harder questions for indices. I've already uploaded a video for the easier questions for indices. If you want to check that out first, please check out the link above. And if you follow that playlist, you will see that I've made a video for each topic that comes in IGCSE Edexcel Maths A higher. You can also use this playlist if you're doing foundation because I've used the easy questions and the harder questions for each topic. If you're looking for the latest exam papers like the May June 2025 one, you can check out the playlist above. So let's start with this one and see how we're supposed to solve the harder questions for indices and how we can make them easier. So it says find the values of n such that 10 to the power of 4n times 2 to the power of 3 times n square minus 5n times 5 to the power of 2 times 1 minus 2n divided by 20 square equals to 1. Show clear algebraic working. So whenever we're trying to solve questions with like indices, we need to make sure that the bases are same. Over here, we have three different bases. We have 10, we have 2, and we have 5. However, we know that 10 can be split into 2 and 5 because 10 is 2 times 5. But for 2 and 5, we cannot further break them down because they're prime numbers. So let's begin with rewriting 10 as 2 times 5 whole power 4n times 2. Whenever we have a power inside the bracket and outside the bracket, we can multiply the powers. So we expand the brackets for both 2 and 5. So that's 3n squared minus 15n times 5 to the power of 2 minus 4n. You can also cross multiply to get rid of the fraction. So it's going to be 1 times 20 squared. Okay, so now we split the 2 times 5 to the power of 4n as 2 to the power of 4n times 5 to the power of 4n because both of them have this power. So let's just split it. And we have these as 2 to the power of 3n squared minus 15n times 5 to the power of 2 minus 4n. 20 squared is 400. So 1 times 400 is 400. Now, what we will do next is we will combine the similar bases. So that means whenever we have similar bases being multiplied, which is one of the rules of indices, we add the powers. So 2 to the power of 4n plus 3n squared minus 15n times 5 to the power of 4n plus 2 minus 4n equals to 400. So that's 2 to the power of 3n squared minus 11n times 5 to the power of 2 because 4n minus 4n is 0. Now 5 squared becomes 25 and we can easily divide 400 by 25 because now it's a constant. So 400 divided by 25, which is going to give us 16. If you notice, 16 comes in the 2 times table and 16 is 2 to the power of 4. So we can easily write it as an exponent. And whenever we have the same base existing alone on both sides of the equal to sign, we can cancel out the bases and put the powers equal to each other, which means 3n squared minus 11n equals to 4. Bring the 4 to the other side, and now you have a quadratic equation. We will solve this quadratic equation to figure out the value of n. We can solve it using splitting the middle term or the quadratic formula, whichever method is easy for you. I'm going to use splitting the middle term. So for splitting the middle term, you multiply the coefficient of x squared, or in our case, n squared, with the constant. So 3 times 4 is 12. Then we find other factors of 12. So that's going to be 6 and 2 and 12 and 1, apart from 3 and 4. Once we've listed down the factors, we pick that set of factors which when added or subtracted give us the middle term, which in our case is 11. So that's going to be 12 and 1 because 12 minus 1 is 11. So negative 12n plus n is replacing negative 11n. So let me just separate this over here. So now next step is to factor by grouping. So we're going to split the equation into two groups. The first two terms make one group and the last two terms make another group. In the first group, we have 3n common. So n minus 4 comes in the bracket. And the last two terms, we have plus 1 common. So n minus 4 comes in the bracket. Now between 3n and plus 1, we have n minus 4 common. So 3n plus 1 comes in the other bracket, which means n equals to 4 and n equals to negative 1 over 3. These are your two values of n. So remember, main thing is to make sure that the bases are same. And if there is a number that is not a prime, like the base is not a prime number, convert it into a prime number base as we did. 10 became 2 and 5. And then after that, combine the similar bases. If the bases are being multiplied, you add the powers. If the bases are being divided, you subtract the powers. And once we did that, we could see that the 5 had just a power of 2. So 5 squared became 25, and we further solved it. And then we were just left with the base of 2. And when we simplified the constants, we got another base of 2, put the powers equal to each other, and we were easily able to find the value of n. Let's just express x in terms of n, show your working clearly, and simplify your expression. So right now we have 18 times root of 27 whole power 4n plus 6 divided by 6 times 9 to the power of 2n plus 8 equals to 3 to the power of x. We know 18, 27, 6, and 9 all come in the 3 times table. So I would like to split these and see how we can rewrite them as a base of 3. And obviously the other factor as well if there's any other. And for the powers, as we know, there's a power inside the bracket and outside the bracket, we multiply them. So like I said in the previous question, we need to create a same base for all the exponents. So we have 3, which is a prime number. So that means we need to make sure that the other exponents have the base of 3. 27 can be rewritten as the base of 3 because 3 cubed is 27. 9 can also be rewritten as a base of 3 because 3 squared is 9. For 18 and 6, if you notice, they're like constants. We can easily simplify 18 and 6 because 18 is being divided by 6 and that is also 3. So let's write this as 3 times square root represents a power of 1 over 2. So that's going to be 3 cubed whole power 1 over 2 times 4n plus 6. Like I said before, when there's a power inside the bracket and outside the bracket, we multiply the powers. Divided by 9 is 3 square whole power 2n plus 8. And this equals to 3 to the power of x. Now let's simplify the powers first. So 3 times 3. Now 3 over 2 is getting multiplied with 4n plus 6. So 3 by 2 times 4n plus 6 over 3 to the power of 4n plus 16. So that's 3 times 3 to the power of, that's going to be 6n plus 9 over 3 to the power of 4n plus 16 equals to 3 to the power of x. If we remember, when you have similar bases being multiplied, we add the powers. So that's going to be 3 to the power of 1 plus 6n plus 9. This 3 has a power of 1. If no power is written, it's assumed to be 1. Divide by 3 to the power of 4n plus 16 equals to 3 to the power of x. So that's 3 to the power of 10 plus 6n. Now, like we said before, whenever we have similar bases being divided, we subtract the powers. So that's going to be 3 to the power of 10 minus 16 minus 6n minus 4n equals to 3 to the power of x. So that's 3 to the power of negative 6. This is plus 2n equals to 3 to the power of x. Same basis on both sides, we put the powers equal to each other. They want an expression of x in terms of n, so that's your answer. X equals to -6 plus 2n. Then it says, given that m equals to 18 to the power of 4n times 2 to the power of 3 times n square minus 6n times 3 to the power of 2 times 1 minus 4n over 12 square. We have to find the values of n for which m equals to 2. So 2 equals to 18 to the power of 4n times 2, expand the bracket, 3n squared minus 18n times 3 to the power of 2 minus 8n divided by 12 square, which is 144. So let's cross multiply. 2 times 144 equals to 18 to the power of 4n times 2 to the power of 3n squared minus 18n times 3 to the power of 2 minus 8n. Like I said before, we need to convert them into similar bases. So we can rewrite 18 as 9 times 2, and 9 is 3 square. So basically 3 square times 2 whole power 4n times 2 to the power of 3n square minus 18n times 3 to the power of 2 minus 8n. Distribute the power like we did in the first question. So that's 3 square times 4n times 2 to the power of 4n. And everything else comes as it is right now. Now we're going to combine the similar bases. So 3 to the power of 8n, like we said, when similar bases are being multiplied, we will add the powers. So let me just highlight the similar bases. So as you can see, for 3, it's going to be 8n plus 2 minus 8n. And for 2, it's going to be 4n plus 3n squared minus 18n. We're just adding the powers for similar bases and writing it under. So 288 equals to 3 to the power of 2 times 2 to the power of 3n squared minus 14n. 3 squared is 9. So 288 gets divided by 9. This is very similar to the first question. Yeah. So 288 divided by 9 is 32. And 32 can be rewritten as the base of 2. Because that's, I think, 2 to the power of 5. Yeah. So 2 to the power of 5 equals to 2 to the power of 3n squared minus 14n. Same basis on both sides, so we put powers equal to each other. And now we have a quadratic equation, which is 3n squared minus 14n minus 5 equal to 0. Now we factorize this. So that's going to be 3n squared minus 15n plus n minus 5 equals to 0. So let me just write that over here. 3n bracket n minus 5 plus 1 bracket n minus 5 equal to 0. N minus 5 bracket 3n plus 1. One value of n is 5 and the other is -1 over 3. These are your values of n for which m equals to 2. Then it is given that 2 to the power of n equals to 2 to the power of x squared times 16 to the power of x times 8, and x is greater than 0. We have to find an expression for x in terms of n and state any restrictions on n. So like I said before, we have to make the same base. And we know that 2 to the power of 4 is 16 and 2 to the power of 3 is 8. So that's 2 to the power of n equals to 2 to the power of x squared times 2 to the power of 4 whole power x times 2 cube. So 2 to the power of n equals to 2 to the power of x squared times 2 to the power of 4x times 2 cube. Similar bases are being multiplied, so we can combine it as a single base and add the powers. Same bases existing alone on both sides of the equal to sign, so we put the powers equal to each other. Find an expression for x in terms of n. So this is n in terms of x. So we have to make x the subject. To make x the subject, we have to apply completing square on this. So to convert this in completing square, what you need to know is what is a completing square. Completed square is, like, for example, a plus b whole square. This is a complete square. Or a minus b whole square. Both of these are complete squares. When you expand this one, that expands to a square plus 2ab plus b square. Whereas this one expands to a square minus 2ab plus b square. Right now we have x square plus 4x, which is our a square plus 2ab. To complete this square, we need to figure out our b square value. So as you can see, our x square is our a square value and 4x is our 2ab value. So from the 4x value, we can figure out what b is going to be. So a square is x square, which means a equals to x. 4x equals to 2ab, which means 4x equals to 2xb because you said b is x. So 4x divided by 2x equals to b, and that is 2. So b is 2. So to complete the square, we do x squared plus 4x plus 2 squared because b is being squared. But we will also write minus 2 squared. And then plus 3 comes as it is. The reason why we write minus 2 squared is because plus 2 squared is a new term being introduced in the equation. So if you're adding something new, you're supposed to subtract it as well. The same logic is applied when we're adding or subtracting fractions with unlike denominators. If you remember, we multiply both the numerator and denominator with the number, not just the denominator. So a similar thing is happening over here, that if we're adding something, we're subtracting it as well. So now the x squared plus 4x plus 2 squared is our part of the complete square. So we will write this as x plus 2, the a plus b whole square. So this comes in the brackets. This is our complete square. And this minus 2 square is outside the bracket. So that's minus 4 plus 3. That's x plus 2 whole square minus 1. Now, there's just one x in the equation compared to what we had previously. So we can easily make that x the subject and make the equation in terms of n. So we do n plus 1 equals to x plus 2 whole squared. Then we take the square root on both sides. So we have plus minus n plus 1 equals to x plus 2. And then we have plus minus root of n plus 1 minus 2 equals to x. So they wanted us to state any restrictions on n. Obviously, n is in the square root. So we know that the value of the square root cannot be less than 0. So keeping that in mind, n plus 1 has to be greater than 0. So n has to be greater than negative 1. That is your restriction. So our expression is, let me just highlight that. This is our final expression, and this is our restriction. So that's your complete answer. And with that, we're done with the questions for indices. Once again, these were the more difficult questions. I have a separate video for the easy questions. So I would suggest that you do the easy questions first, understand the basics, and then move on to the harder questions. If you understood everything, please like and subscribe and share this video with your friends. If you still have any confusions, please comment below. I'll help you out. And don't forget to check out the other videos that are in this playlist.